All right, so these are the notes for exponential growth and decay functions. So to start this off, an exponential function has the form y equals abx. So an exponential function has the form y equals a times b raised to the x power, where a cannot equal 0, and the base b is positive, real number, other than 1. All right, so we kind of remember what it looks like, so we can see this general function that we've seen in our parent functions at the very beginning of the school year. So let's kind of go into a little bit further. So the parent function for exponential growth. So we're talking about exponential growth functions. So if your a value is greater than 0, which just means it's positive, and your b value is greater than 1, then y equals abx is an exponential growth function. And b is called the growth factor. All right, and the simplest type of exponential growth function has the form, it's just without the a, y equals b to the x power. So right here, you can see the graph from left to right. It rises up. It starts off real slow, then it just picks up real fast. It says the x-axis is an asymptote, so that's a boundary line that our graph cannot touch or cross. Even though it looks like the line's touching it, the graph, it's not actually touching it. An asymptote is a line that a graph approaches more and more closely, but it never does touch. The graph rises from left to right and passing through the points 0, 1, and 1b. So whenever I'm creating a table for this, so just see, when I graph these, I use that function, b to the x power. I use the values -2, -1, 0, 1, and 2. And then from here, what I go ahead and do is I just plug in the numbers for b. So I start with this b to the 0, then b to the first, b squared, b to the -1, and b to the -2. So here we can see that I'm plugging in these x values for that x there. So b to the 0 is 1, b to the first is b, and b squared is obviously b squared. And we go backwards, b to the -1, we can't have negative exponents, so we move the b to the bottom. And since there's nothing left on top, we put a 1 there, so it's 1 over b. So notice it's the reciprocal of this one. So this is b, this is 1 over b. This is b squared, this would be 1 over b squared. So that's just a general table when you don't have transformations that you can use. If you notice from left to right, it does go up. So the domain here is going to be all real numbers. I like to use -infinity to infinity. The range is y is greater than 0, so notice the asymptote means it's not included, or you can use 0 to infinity. All right, on the other hand, we have the exponential decay function. So same thing, a is still going to be positive, so a is greater than 0, but your b value is going to be between your two numbers. It's not negative, it's between two numbers, 0 and 1. So 0 is less than b, but b is less than 1. Notice it's not equal to either one of those. Then y equals abx is an exponential decay function. And b is called if the other one is the growth factor, this would be the decay factor. All right, and in terms of the setting up, making the table, this is the exact same thing. You would use that to set it up the exact same way. The graph here shows the general shape. So notice here from left to right, this one went up. That's growth, getting bigger. This one, it starts off big and it gets significantly smaller really quickly. So that's decaying. So the graph falls from left to right and it passes through these points. So you notice 0, 1, and 1b. That was in here, 0, 1, 1b. This one also had the same point, 0, 1, and 1b. So you're going to see those common points. The asymptote is going to be the exact. It's still going to be the x-axis, and the x-axis is an asymptote. And the domain should be the same. All real numbers. So -infinity to infinity. And y is greater than 0, so 0 to infinity. So you see there's a lot of similarities between the two. Just one, growth goes up from left to right. Decay falls down from left to right. All right, from here, I'm going to take a look at these two graphs really quickly. So it says graphing growth and decay functions. Tell whether each function represents exponential growth or exponential decay, and then graph the function. So right here, y equals 2 to the x power. Here, if I wrote the form y equals a times b to the x, I don't see an a, so I'm just doing b to the x. The b value is 2, which means it is growth. And then I'm going to create that table xy. So 2 to the x power, so negative 2, negative 1, 0, 1, and 2. So 2 to the negative 2 power, 2 to the negative 1, 2 to the 0, 2 to the first, and 2 squared. I always start with 2 to the 0. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4. And just like previously, it was the reciprocal. So 2 to the negative 1, the reciprocal of 2 is 1/2. The reciprocal of 4 is 1/4. Now we just take these points and we graph them. So 0, 1, 1, 2, 2, 4, negative 1.5, and 1/4. And I know there's an asymptote here because there's no transformations moving it up or down. And then I just draw my graph the best I can, trying to get through these points. All right. So once again, you just look at the b value. If it is greater than 1, it is growth. If it is between 0 and 1, it is decay. And you can always tell the b value because it's the number raised to the power of x. All right, for letter b here, the b value here is the 1/2. And since that's between 0 and 1, that is going to be decay. So from here, xy, 1/2 raised to the x power. So negative 2, negative 1, 0, 1, and 2. And just like before, we're going to take these and raise them to the powers now. So 1/2 to the negative 2, 1/2 to the negative 1, 1/2 to the 0, 1/2 to the first, and 1/2 squared. So 1/2 to the 0 power, anything to 0 power is 1. 1/2 to the first is 1/2. 1/2 squared, so 1 squared is 1. 2 squared is 4, so 1/4. We take the reciprocal with the negative power, so 1/2, the reciprocal is 2. 1/2 to the negative 2 becomes 4, so reciprocal. So I'll make my points. This one should be coming from left to right, coming down. Let's just make sure. Don't forget your asymptote. So we see decay does fall, growth rises. If you look at both of them, both domains are all real numbers. And the range is both 0 to infinity because it does not go past that asymptote.